So the second video for section 2 is just going to go through the 4 examples applying the perpendicular tangent theorem and the congruent tangent theorem. So if we look at this first example, it asks us to find AC. And AC is really the hypotenuse of that triangle formed by the tangent, the radius, and that extra line. And so we've got 5, 8, AC is the hypotenuse, and so again, a very straightforward Pythagorean theorem problem. H squared is equal to 5 squared plus 8 squared. And when I work that out, I end up with H being the square root of 89. This next problem applies that congruent tangents idea. And just again quick, if we think about looking at this where we draw a radius in, that's equal, we draw a radius in, that's equal, we know that these are at right angles. If we draw this diagonal in, but reflexive, it equals itself. So we've got a right triangle, we know the hypotenuse and the legs are congruent. These two triangles are congruent by HL, which means by CP/CTC, those pieces are equal. We don't have to go through that big extensive proof every time because of the theorem, but if AB is 4, AH is 4. Now I can't figure out GH right away because I need to kind of backtrack. If CD is 8, CB is 8. If DE is 3, FE is 3. Parts to whole, if FE is 3, the whole thing is 6. This is 3, which makes GH 3. Now, perimeter is distance around, so we're going to add up all of the pieces. Just be careful to not double add on that one side where we had multiple numbers. So we're going to add all of these numbers up. Careful not to double anything up. And when we add them all together, we end up with the perimeter is equal to 36 units. And since it is perimeter, it's just a units. Now this one has some interesting pieces in it. We have that tangent line that forms the right triangle. But I'm given this exterior piece. I do not know that this piece and this piece are bisected. I can't assume that. So this piece here is not 8. Okay, so what I need to do is I need to say, well, I'm going to give this whole piece a different number. I need the sum. Well, what is this piece to this piece? It's a radius. This piece to this piece is the radius. So I know that this is 12. So the whole thing is 20. So it's a really useful thing to remember and always be looking for different, no matter where I draw a radius, it's always 12. So now my right triangle looks like this. And I can set up, careful, 20 squared, always start with the hypotenuse, longest side opposite the right angle is equal to 12 squared plus x squared. And when I get done with that math, I end up with x squared being equal to 256. And so x is 16 when you take the square root of both sides. Last example, we've got a triangle circumscribed around the circle, and we want to find TW. So this is going to rely on those perimeter pieces. Since I know this is 9.5, I know this is 9.5, I know this one is 3. I could find out this one is 3. I don't need it, but I do. I can't say anything about these, but if I add 9.5 and 3, I get 12.5, which is TW. So that is a couple extra pieces about circles, and good luck on your homework.